movie is pumping iron. As you can tell, Brett does like to pump iron. With that image, let Brett take it away.
Thanks, Brendan. So I'm going to be talking to you today about my thesis research, which I started in September of 2008. The title of the talk is Monitoring and Reducing Rockfish Bycatch in the BC Spot Prawn Trap Fishery. But before I go too much further, I want to just start kind of framing the issue of marine conservation in general. Fisheries around the world have depleted many stocks, and this image I think really encapsulates at least what the North Atlantic looks like. This is a calculation of what we think the North Atlantic looked like in 1900, where everything that's red means there was a lot of high trophic level species like cod that we like to eat. 100 years later, you can see that there was quite a sharp decline, with all those areas in red are kind of non-existent anymore. So fisheries catch has been a real problem for conservation. And the aspect of fisheries catch that I study is bycatch. Intuitively, bycatch is when you fish for one species and you catch something that you weren't intending to catch, though there's many other different formal definitions of it. It affects all taxonomic groups. This is a whale, a sea turtle, a shark, and a sea lion. So it's a real problem across all different species and groups. In fact, it accounts for between 8 to 40% of global marine catch, depending on how you specifically define the word bycatch. So no matter what way you look at it, it takes a lot of animals out of the ocean that wouldn't need to be removed otherwise. Shrimp trawling is the #1 culprit when it comes to bycatch. On average, around the world, you catch about 5.7 kilos of bycatch for every kilo of shrimp or prawns that you catch with trawling. In addition to the bycatch, you also have this issue of destruction of benthic habitats. You can imagine this net scraping along the bottom of the ocean and taking out everything that is in its way. To be fair, there have been a lot of efforts to improve shrimp trawls, and different devices that exclude sea turtles and other creatures have been put into effect that have reduced the amount of bycatch, at least of charismatic species. But there's still, this figure is still thought to be true today. At the extreme end, some shrimp fisheries can produce 20-to-1 ratio of bycatch to shrimp catch. And this is a picture of what that kind of looks like. This is the result of a shrimp trawl somewhere in the tropics, and basically it's a big pile of fish and a few little shrimp here and there. So it's a real problem. This discussion of shrimp fishing leads me to talk about the fishery that I study, which is the BC Spot Prawn Trap Fishery. And this fishery is unique in that rather than trawl nets, they use traps to catch prawns. These are spot prawns, caught locally here. They're big, juicy, tasty animals to eat. And this is a representative, I think, prawn trap fishing, where you can see the trap stacked on the top of it. Trapping is assumed to produce minimal bycatch and habitat destruction, and this is one of the main reasons that it's endorsed by Oceanwise and Sea Choice and other conservation organizations as a more sustainable choice for seafood. Economically, this industry is very important. There's about a $30 million annual landed value in British Columbia, and it's the 4th largest shellfish fishery in our province. There's about 220 boats involved in the fishery, and each boat employs a number of deckhands, plus all the secondary industries that process the food. So it does make a big economic dent on our province. Let's have a closer look at this fishing gear. This is a prawn trap. It's a very lightweight device, and you can tell from this picture, the scale, they're about this big. And it's comprised really of only 4 major parts. The opening, which is a 3-inch diameter, usually a stainless steel ring. Everything has to pass through the opening to get into the trap. There's a bait can in the middle of the trap, and that's where you put your prawn pellets or whatever other bait you choose to use when you're fishing. It's a stainless steel frame with a mesh wrapped around it. So this is really the 4 parts that make up this whole fishing gear. So it's very, very simple, very lightweight, and convenient to use. When deployed commercially, prawn traps look sort of like this. So you have a buoy at the surface, a long rope, which is a lead-lined fishing line basically, and that goes down, it's attached to a weight at the bottom. It runs along the bottom, and they clip 50 traps to this long string. At the other end of the string, there's another weight, and it goes up to a buoy. And these are deployed usually about 50 to 200 meter depths. Now, prawn trapping is much more selective than trawling, but it still produces some bycatch. And my research is considered with the bycatch of rockfish. This is a quillback rockfish that was brought up in a prawn trap. And as you can gather from the picture, they don't survive this capture process. In fact, it's 100% fatal. When you bring a rockfish up from deep water, they have an enclosed swim bladder which expands and then ruptures. So the fish can no longer submerge once they're at the surface, and they get picked off by predators such as eagles. In addition, their eyes pop out of their sockets, their stomach inverts, and they have all kinds of other problems that are not conducive to survival. As a whole, rockfish are a very diverse group. There's about 65 species on the Pacific coast of North America. This is a black rockfish, a copper, and a quillback rockfish. They're a highly diverse group of mesopredators that play a very poorly understood role in the ecosystem. So despite the fact that these things live all over the coast, we actually don't have a great understanding of what role they play in shaping the community or anything else like that. And these populations of rockfish, many of them have been depleted due to overfishing. You know, when you don't know a lot about a group of species, it's kind of hard to manage them. And this group of species also has a lot of life history characteristics that make them prone to overfishing. They have a very long lifespan. The oldest one ever recorded was 205 years old, a rough-eye rockfish up in Alaska. This is a rough-eye down here. And with a long lifespan comes a late age of maturity. And when it takes a species a while to reach sexual maturity, it means they have to survive quite a while before they can start seeding the next generation. So it means that you have to basically protect them for longer before they can start helping seed the population. Secondly, recruitment is variable, and it's poorly understood. So we don't really know what environmental factors facilitate the survival of juvenile rockfish. And fecundity and larval quality increases with maternal age. So those big, old female rockfish that can produce millions of eggs a year are the ones that we actually like to target for fishing as well. So it's a direct conflict between the life history of rockfish and the type of fish that we like to target. So all these factors together are contributing factors to the depletion of many of these different populations. In response to a lot of these declines, the Department of Fisheries and Oceans instituted a conservation strategy which involved the creation of rockfish conservation areas. Everything in this map that's red is a rockfish conservation area, and in these areas you're not allowed to target rockfish. Now, because prawn trapping is assumed to produce very low amounts of bycatch, that fleet is actually allowed to fish in all these different areas. And what it means is for the industry there's this concern that if it does turn out that these rockfish are showing up in the traps at a significant rate, there's the risk that they would be excluded from these areas. And you can imagine if you're a fisherman and you're looking at this, that's a lot of area that you're no longer allowed to fish in. So the economic cost of that could be substantial to the industry. So that brings me to why I'm here, and that's bycatch reduction. My job is to design, construct, and test a modified trap that convincingly reduces rockfish bycatch while maintaining existing prawn catch. So what I'm going to talk to you about today is, first of all, how much bycatch do we think actually occurs in prawn traps? I'm going to talk about work that I've done so far to develop a solution to this problem. I'm going to talk about how I'm going to be testing this solution in the future and hopefully come up with something that's workable for the actual industry. So first of all, how much bycatch occurs in prawn traps? And secondly, why is bycatch at all hard to measure? So when you first approach an issue like this, you would think it'd simply be a matter of looking at logbooks or something like that, but it's not that simple when it comes to bycatch. One reason for this is that catch is discarded immediately. So when fishermen catch different species on their boat, usually the first thing a fisherman will do is dump the contents of their trap or their net or whatever into a sorting tray, and immediately they'll put the non-target species back in the water. It makes it a very complicated, it's a hard thing to sample because you have to slow down the fishing process usually to recover those animals. There's a confidentiality issue. So if you're a scientist not affiliated with government and you're approaching fishermen trying to get on their boats to look at their bycatch, there's a massive confidentiality issue. Imagine you're trying to go to KFC and you want to learn how they cook their chicken. They're not going to tell you the secret recipe. This is a proprietary thing. It's no different on fishing boats. When you go on a fishing boat, you're learning how and where they fish. You're learning little things like how do they make their fishing process go efficiently, but you're also learning big things like where do they fish. And this is something that they build up over a lifetime to find these areas that are productive. And it can mean the difference between a successful and an unsuccessful boat. So you have to build a real trust relationship with these guys to convince them that you're not going to share where they fish or share how they fish or different things like that, and that you're just going to look at their bycatch. There's also a lot of variability across geographical regions often. So you're using the same gear in the same manner over here versus over there, and you're going to get a different catch composition. So if you're going to have an effective sampling regimen, you really have to do it over a large scale. And so that means that it can be very expensive, both for a scientist if you want to travel to these different areas, or for a government if you're trying to create a sampling program that actually looks at the bycatch in a fishery. And finally, there's an incentive to underreport bycatch. There's the obvious issue that if you're a fisherman, you don't want people to know that your industry is catching things that they're not supposed to be catching. But there's also another very practical issue, and that's that fishing occurs very quickly. And the time it takes to stop and write down your bycatch can be an inconvenience for people. So every time people seem to study this, where they go and actually compare a fishery before and after an observer program was put into place, the bycatch always goes up after observers show up on the boats. So this is definitely an issue in bycatch research.